So we left over last time with the question of what exactly is a cloud. When you ask different people in industry or in academia what a cloud is, they'll give you very different answers. Some will say, oh, it's just a cluster, a bunch of servers strung together by a network. Others might say, no, it's a supercomputer. It has more power than a simple cluster that you might run in your lab. Others might say, no, it stores a lot of data, so it's different from a supercomputer because it stores data rather than computes things. Others might say, well, it can do a lot more things than all of these together. And some of the folks you ask will say, well, it's none of the above, it's a completely different beast. And others will say it's all of the above. So there is no single definition for a cloud itself. It is often taken to mean not just compute and storage resources, but also include the network and so on and so forth. For the purposes of this course, however, I'm going to come up with a very simple definition. It's a working definition. It's not perfect. It's not meant to be perfect. It's meant to be good enough for us to learn more about the technologies that exist out there. So the working definition says that a cloud consists of a lot of storage resources, so you can store gigabytes, terabytes, petabytes, maybe even more of data, with compute cycles located nearby. Notice that this definition is not the reverse, which is that it doesn't say you have compute cycles with data moving around. Essentially, there is so much data, it is a data-intensive world that we live in, that you can't really move around the data all that easily. So you need to bring the compute closer to the data rather than bring the data closer to where the compute is. And you'll see this theme coming back several times as we move along in the lecture and in the course. So what is a cloud? There are two kinds of clouds, a single site cloud or a geo-distributed or geographically distributed cloud. A single site cloud, known as a data center often, consists of the following components. Of course, it consists of servers or compute nodes. These are grouped into racks. A rack is a unit of several servers which typically share the same power and often share a top-of-the-rack switch. These top-of-the-rack switches are often connected via a network topology, for instance, a tree-like topology, a hierarchical topology, one of the most popular being just a two-level tree where you have the top of the racks at the one level, and then you have the core switches connecting all the top of the racks to each other. In addition to these nodes which are used for computing, the servers, there are also back-end nodes, also in the racks, but those are predominantly used for storage. These might be nodes that have SSDs or larger or more hard disks on them. And then there are user-facing servers where the client requests come in or users can submit jobs if it is a batch processing system. And finally, there is software that is running at all of these servers as well as the routers. The software includes operating systems, it includes user-level applications, it includes the actual IP protocol at the switches and the routers, and it also includes other routing protocols. So that's a single data center. Typically, such a data center is housed in a single building or a single warehouse in the case of some of these large companies. But a large company might also have multiple geographically distributed data centers, and they might be connected to each other. So these are multiple sites, each site being a data center, and this is often called a geographically distributed or a geo-distributed cloud. Each site typically has the same structure and services as the other, or at least as far as the software is concerned, it has the same software stack. But this is not a hard and fast rule. Different sites might have different software stacks. So let me illustrate a sample cloud topology, a hierarchical topology, which I was talking about in the previous slide. You have the servers at the leaves of the topology, essentially. The servers are grouped into racks. There is a top-of-the-rack switch, which connects all the servers that are in that rack. And then there are multiple such racks, obviously. Here I'm just showing two racks, but there might be multiple such racks. And there is a core switch as well. Obviously, all of these core switches and top-of-the-rack switches are limited in terms of bandwidth and in the number of ports that they have. So if you have many more servers than the core switch can support, then you may need to grow out your topology to be more than just two levels as you see here. But then that still begs the question, what is a cluster? Because this, after all, looks like a cluster, right? So what is it that is new about cloud computing that was not previously there in the clusters that we already know of?